Hi, today we are going to discuss about graph traversal using breadth first search BFS method. BFS breadth first search method. Traversal means visiting all the nodes of the data structure. Here, the data structure is a graph where we wanted to visit all the nodes of the graph using breadth first search. There are two different methods to traversal a graph. One is depth first search, the other is breadth first search. Now we are going to discuss about breadth first search. Breadth first search is a graph traversal algorithm that starts from a source node and explores the graph level by level. First, it visits all the nodes directly adjacent to the source. Then, it moves on to visit the adjacent nodes of those nodes, and this process continues until all reachable nodes are visited. BFS is different from DFS in a way that closest vertices are visited before others. We mainly traverse vertices level by level. Here, there is no specific start vertex. You can start traversal of a graph from any node. For example, in this particular graph where we wanted to traverse using breadth first search, assume that V1 is source vertex. Assume that V1 is our source vertex. So first we visit V1 source vertex. V1 is visited, source is visited, source visit, visit source vertex. V1 is visited. Then find adjacent vertices. Find adjacent vertices of source vertex. What are adjacent vertices? V2, V3, V8. Directly adjacent to V1, V2, V3, V8. Visit all the adjacent vertices. V2 is visited, V3 is visited, V8 is also visited. See, initially V1, then V2, then V3, then V8. Now, from the adjacent vertices, take the first vertex and find the adjacent vertices of the first vertex. The vertex V2 adjacent of V2. Adjacent of V2 are V1, V4, V5. V1, V4, V5. But V1 is already visited. So, unvisited adjacent vertices V4, V5. Visit V4 and V5. V4, V5 also visited. Then, the next vertex we have to choose is V3. Find adjacent of V3. Adjacent of V3 are V6, V7, V6, V7. Other than V6, V7, V1 is there. V1 is already visited, so we don't consider V6, V7. So V6, V7 also visited. Visit V6 and V7. V6, V7 also visited. So almost all the vertices here they are visited. Initially V1 is visited, then adjacent of V1 are V2, V3, V8 they are visited. Then adjacent of V2 are visited, V4, V5, then adjacent of V3 are visited, V6, V7. So all the vertices that are there in the graph have been visited. The order we have got while visiting using breadth first search is V1, V2, V3, V8, V4, V5, V6, V7. For this, we use a queue. We use a queue. How to traverse or how to visit the nodes using breadth first search. With the help of queue, I will explain. Let me explain the algorithm to traverse the graph using BFS method, breadth first search method, which uses a queue so that it is nothing but an application of queue. Here we use a queue. See the algorithm BFS breadth first search vertex V. It is source vertex. Assume that we select any vertex as source vertex. Assume that BFS V1. BFS V1 means Breadth first search starting from node V1. Starting from V1, we wanted to visit all the nodes of the graph. What it follows, it has a queue. Assume that there is a queue. This is a queue where initially it is empty queue. Initially it is empty. Now visit V. Whatever the node V1 is your source. V1 is visited. Visit V1. Then initialize queue is empty. Add V to queue. V1 is inserted in the queue. Now queue contains V1. While queue is not empty. See here, while queue is not empty. Yes, it is not empty. Queue is not empty. Queue has one node. Delete queue. Node is deleted. Now V is V1. All adjacent vertices. For all vertices W adjacent to V, if not visited, means all the adjacent vertices. What are adjacent of V1? V2, V3, V8. For all vertices W adjacent to V, if not visited, yes, V2 is not visited, V3 is not visited, V8 is also not visited. Add them to Q. V2 is added to Q, V3 is added to Q, V8 is added to Q. Then visit them. Visit V2, V3, V8. So 4 nodes have been visited. Then what happens? See the while statement. This is the body of while statement. First time all the statements have been executed. Then again it checks while it is not empty. While Q is not empty. Yes, Q has 3 elements. It is not empty. Then delete one more. Delete. Now V is V2. Delete. V2 is deleted. Delete Q. You may get V. V is the new node, that is front node V2. V2 is deleted. For all vertices W adjacent to V2. V2 adjacent nodes of V2 are V1, V4, V5. But we are looking for only unvisited vertices V2, V4 and V5. Add them to queue. V4 is added to queue. V5 is also added to queue. Then visit them. Visit V4 and V5. Visit V4 and V5. Then again, while queue is not empty, yes, queue is not empty. Delete once again. So now we becomes remove one node V3. It becomes V3. For all vertices W adjacent to V, it is nothing but V3. What are adjacent vertices? Adjacent vertices are for V3, the adjacent vertices are V1, V6, V7. V1 is already visited. The unvisited vertices V6, V7. If not visited, yes, if not visited, add it to queue. V6 is added. V7 is also added. Then visit V6 and V7. Then again, while it is not empty, yes, it is not empty. Delete one more node. V8 is deleted. Now V is V8. For all vertices W adjacent to V8 adjacent of V8 are V4, V5, V1, V6, V7. Yes. If not visited, all are visited. V4 is visited, V5 is visited, V1 is visited, V6 is visited, V7 is also visited. Then we are not doing anything. Again, while not empty of Q. If Q is not empty, yes, Q is not empty, Q got some more nodes, V4. Again, delete node. Now we are going to delete another node. V4 is deleted. Now V becomes V4. Is there any, for all vertices W adjacent to V, is there any adjacent vertices? Adjacent of V4 is V2, V8. V2, V8. If not visited, is V2 visited? Yes, it is already visited. V8 already visited. So again, while it is not empty, yes, it is not empty. Again, remove one more data item, V becomes V5. Find adjacent vertices. Adjacent of V5 are V2, V8, V2, V8. If not visited, they are already visited. So again, we go to while control, while not empty, yes, V is, again remove one more item, V6, delete, Q, V6, adjacent of V6, adjacent of V6 are V3, V8, V3, V8, V3, V8 already visited. Yes, here visit V3 and V8 are already visited. So V3 already visited, V8 already visited. We don't do anything. Again, we go to delete one more item. V becomes V7. Adjacent of V7, V3, V8, V6. Adjacent of V7 also V3, V8. V3, V8 already visited. So it goes to end of function. So the sequence we have visited is here V1, then visit V2, V3, V8, V1, V2, V3, V8, then visit V4, V5, V4, V5, then V6, V7, V6, V7. The sequence is this: first node, second node, third node, fourth node, fifth node, sixth node, seventh node, eighth node. All 8 nodes have been visited. So in this way, we traverse or visit all the nodes if we select V1 as start vertex where BFS uses Q in the algorithm to traverse all the nodes. So BFS can be treated as an application of Q. Let me explain the graph traversal using BFS method, breadth first search. Breadth first search uses Q. So breadth first search method is considered as an application of Q. Application of Q, as it uses Q to traverse or to visit all the nodes. We can select any node as start vertex in the graph selected in here. Here there are 8 number of nodes. Select V1 as your start vertex. And this graph traversal uses a queue. Assume that there is a queue. Initially, we initialize that to an empty queue. There are no nodes 0, 1, 2, 3, 4, 5, 6, 7, 8. We can select some number of nodes. We can add some number of nodes here, 9, 10, any number of nodes. So select some queue and initialize it to empty. And we are selecting V1 as the start vertex. So we start visiting nodes from V1. The two different operations of queue are add node and delete node. We can add a node to the queue. We can delete a node from the queue. Add node, delete node. As we have to start visiting nodes from V1, first add V1 to the queue. So V1 is there in the first slot, first location of the queue. Now we check, is queue empty? No. As long as queue is not empty, delete a node. So V1 is deleted from the queue. V1 is deleted and visit V1, visit it, visit V1, find adjacent vertices. Adjacent vertices of V1 are V2, V3, V8, V2, V3, V8. Add them to queue. Add them to queue. V2, V3, V8 are added to queue. Then visit V2, V3, V8, V2, V3, V8 are visited. So V1 is visited. Then V2, V3, V8 also visited. Now, while queue is not empty, is queue empty? No, queue is not empty. It contains three more nodes. Delete one node, V8, V2. V2 is deleted from the queue. Find adjacent vertices of V2, V1, V4, V5, V1, V4, V5. But V1 is already visited. Now V4, V5 are unvisited vertices. Add them to queue. V4, V5. Then add V4, V5 to queue. Then visit them. V4, V5 are visited. So V4, V5 are visited in the third stage. Then again, while queue is not empty, yes, queue is not empty. Again delete one more node, V3. V3 is deleted. Find adjacent vertices of V3, V1, V6, V7, V1, V6, V7. V1 is already visited. Then V6, V7 are unvisited vertices. Add them to queue. V6, V7 are added to queue. Then visit them. V6, V7 are visited. See here, V6, V7 are already also visited. Then if queue is not empty, yes, queue is not empty. Delete one more node V8. V8 is deleted from the queue. Find adjacent vertices V4, V5, V1, V6, V7, V4, V5, V6, V7. Are they visited? Yes, they are already visited. So they are not unvisited vertices, they are already visited. Then delete one more node V4. V4 is deleted. Find adjacent vertices V2, V8, V2, V8. Are they unvisited? No, they are already visited. V2, V8 are visited. So delete one more node V5. V5 is deleted. Find adjacent vertices V2, V8, V2, V8. Are they unvisited? No, they are visited. Then delete one more node V6. Find adjacent vertices V8, V3, V8, V3, V8. Are they unvisited? No, they are visited. Remove one more node, delete one more node V7. Find adjacent vertices V3, V8. Are they unvisited? No, they are visited. So is queue empty? No, yes, it is empty. As long as queue is not empty, the process is repeated. Now the queue became empty. It is empty, empty queue. So all nodes have been visited in the order V1, V2, V3, V8, V4, V5, V6, V7. For traversing nodes in breadth first search method, we use queue. In this way, we can traverse or visit the nodes from start vertex to all other nodes, right? All the nodes of the graph have been visited using the start vertex, using breadth first search method, where it uses a queue, which is nothing but it is an application of queue. Breadth first search is an application of queue. Thank you.